All right, now that you've learned all about volumes and bind mounts and why we need to worry about persistent data, let's do something that's a real world scenario, which is database upgrades. So imagine a situation where you're running a particular version of a database, let's say Postgres, and you're needing to update the patch version because maybe there's a security fix or a bug fix or something, and normally on a system, you would just update the software. You do a package management system update or upgrade, and it would handle all the updates of the libraries and everything by itself. But how do we do that in a container? Because if we're trying to follow the best practice of not updating applications in containers, but rather replacing the container with a new version, how do we do that with a database? So what you're going to do for this assignment is you're going to use Docker Hub to get you some info around updating the specific version of Postgres. And we're going to start with you specifically creating a container using version 9.6.1, which is an older version. And you're going to need to create a named volume. So you're going to have to lean on Docker Hub's documentation for this using the official Postgres repository. And you'll need to go into the Docker file for that specific version and learn what the volume path needs to be. And then you can name your volume whatever you want on the left side, but remember that colon on the right side of it, that has to be the path where the actual databases are going to be in the container. And so once you've got all that figured out and you started your container, you should start checking the logs to see when it's finished creating the databases and all the startup stuff. Because the first time you start a database container, typically it does a bunch of stuff in the background, like creating the admin user and a default database and so on. So there'll be a point where the logs will stop and then it'll just be running. So if you've done it correctly, you'll be able to do a Docker volume ls and see the volume listed there with the name that you gave it. And you should be able to stop that container. And then you're going to create a new container with a new version. So it's going to be a very similar command to the first one, only you specify a different version. You'll also make sure you want to specify the same name volume because it needs to be using the data that you used in the first one. And of course, make sure that you have the first one stopped because both of these can't access the same data at the same time. And once you've started it, then go ahead and check the logs again for that new container. And what you should see is that it only has a couple of lines of startup logs because it doesn't have to do all the work of the initial startup. That's kind of how you know it's using the same named volume, is that the second time it starts up, it may only have 4 or 5 log entries. And so this is a real world scenario. You'll do this if you ever run production databases or anything that you need to keep current. But do note that most database systems don't do major upgrades automatically. It usually requires a tool. With Postgres or MySQL, there's a separate tool for each one of them that you have to run. So this is really just about upgrading the patch versions or that last number, which doesn't require schema changes or any major updates to the data code itself. And like before, if you get stuck, no worries because this is a new thing and it may not be that clear in Docker Hub. So if you get stuck at some point and Docker Hub isn't helping you out, just check the next lecture, which is me going through this same exercise as I would do it. Good luck. Okay, so this is me going through the named volumes assignment for updating a database. So I know it's supposed to be Postgres, and I'm probably going to need some information from Docker Hub. So let me switch over to that. Okay, so it says I need to start with version 9.6.2. No, I'm sorry, 9.6.1. I'm supposed to go to 9.6.2, start with 9.6.1. So I don't see 9.6.1 in here, but I can actually find that over here, hopefully in tags. So I'm just going to search the page for 9.6.1. All right, there we go. Cool. And now this is actually a different way to look at what the Docker file is doing. So I could, yeah, it's got a volume path right here. And I'm going to assume that that's the same volume path for both because they don't change that kind of thing very often. And I'm going to call it 9. So, okay, Docker container run. I don't have to worry about ports or anything because we don't need ports for this. I'm going to use a -D to put it in the background. And then I'm just going to name it psql. And then I'm going to call the volume psql. Then I'm going to paste in that volume to store the data. And then need to call the container post, or the image. I need to type the image here, 961. Okay. Now, Docker container logs, follow. I want to do the -f command so that it keeps watching as it runs. Okay, I think it's actually done booting. Database system is ready to accept connections. Okay, so I'm going to Control-C out of that. So that's good. So I'm going to do a Docker container stop psql. Now I'm going to hit the up arrow. I'm going to change this to a 2. I need to change the name to a 2, so because I can't have 2 with the same name. Okay, now if I do a Docker container ps-a, I should see two different versions, one that stopped a few minutes ago. I do a Docker volume ls. I can see that I have one volume with that correct name. If I do a Docker container logs on this one, yep, very short logs there. And yeah, its database system is ready to accept connections. So I successfully updated. Okay, I'm super excited about this assignment for you because bind mounts can be really cool. And they're particularly cool for local development or local testing because, as we've explained before, they're going to allow you to edit files on your host operating system, and then they're actually running or being used inside the container to do things in a much easier way. So in this example, we're actually going to be using something called a static site generator. And this isn't specifically a web developer assignment. We're not actually going to be doing much other than editing a line of text. Really, what this is about is getting used to the idea of taking host data that you have on your host machine and then mounting that into a container and then changing it on the host and watching it be reflected inside the container, right? So in this case, this is a pretty common example. A web developer has source code and HTML and all that on their host, and they normally would have to download all the special tools they need on the host, right? We would need the programming language tools, a web server, some sort of file watcher that detects changes and restarts things, and all these tools, right? And that's normally a big thing for web developers, is to figure out how to make all that work on their particular operating system and all the right versions. But the cool thing is in Docker Hub, so many of these problems have gone away because the stacks of those components are all inside a single container and somebody has done all the hard work for you. So in this case, we're going to actually be using Jekyll. And like I mentioned earlier, it's an SSG. Those are really very basic tools that allow you to create Markdown, which is basically plain text. And then it takes those and generates it into an HTML website. So it's really great for small blogs or simple websites where you don't want to have to be an HTML guru and you just want to write something simple and have it posted on the web. This is also, whenever you see sites run by GitHub, known as GitHub Pages, Jekyll is also the tool that they use. So in this case, you're going to jump into the bind mount sample directory as listed here on the slide, and you're going to see some files there. And you're going to edit those with your editor of choice, whether it's Visual Studio Code or Atom or Vim or Sublime Text or whatever you like. And we're going to have a container running in the background that's running Jekyll and watching those files on your host and detecting updates and then automatically updating the web server that's built into the container. And to get you started, here is the command you can actually use. So you want to jump into that bind mount sample directory and then run this particular Docker run command, which will open up your default localhost and actually map that directory. Remember, the pwd will map that into the site directory inside the container, which is what we've set up here. And then I've made you a custom Jekyll container that's really easy to use, and it's using all the latest versions. And so what you should see is you should be able to run that, open up your browser to localhost, see the website there with the basic web page. It's actually using the default template. And then you're going to just quickly jump into the post directory that's inside that bind mount sample. You can actually see it here on my screen. I actually have it in my Visual Studio Code. So these will be the files inside that directory, and you'll just go into this file here, which is a markdown file, and it's okay if you're not a markdown guru, and you just need to change something in here and then jump over to your web browser and notice how it's reflected automatically as an update once you save the file. And of course, I highly recommend looking at the logs inside Docker to see what it's doing, because it'll actually tell you every time a file is changed and it's reloaded the server. And if you get stuck, or if this doesn't make sense to you, just watch my answers lecture video right after this, and I'm going to run through this and you can follow along if you get stuck. Good luck. Okay, this is me walking through the assignment on bind mounts, and I start out here in the bind mount sample 1 directory. And if I look here, I see some markdown files and other things. I don't really have to care about those, but those are the standard template files from a Jekyll website. So I know normally if I was wanting to use Jekyll on my machine, I'd have to actually install Jekyll, which requires a specific version of Ruby and other tools. The nice thing here is I don't have to do any of that. So I can type the docker run. We can also type docker container run, but I'm going to use the shorthand form here. And I'm going to forward port 80 to port 4000 in the container like we specified. And then I need to mount this directory into the container, into that site directory. And then I need to run the Jekyll serve image. Okay, I can see what happened here was when it actually started up Jekyll, it actually built this website from those source files. I don't actually have to know what all that means, but I can tell down here at the bottom that it's actually started and the server is running, and I can press Control-C to stop. So then let me go over to my browser and type localhost. Okay, default website. And it looks like it has one post, which is this page here. All right, so now I'm going to go over to my code editor, and I'm going to pull up that post file like we talked about, and I'm going to change something in here. I'm going to actually change the title. And I'm going to save it, and it looks like my logs back here say, it's detected the changes in that file. And then if I go back over to my browser and hit refresh, there we go. So as you can see here, my files are correctly being mapped into the container. The container sees the file changes on the host and then updates its code. There we go. And if you're interested in Jekyll, Jekyll's actually a really cool static site generator. It's great for making websites on GitHub, which are free, by the way. And you can find more information about it here. But instead of actually installing it the way they're suggesting, you can go ahead and use my container or build your own. And if you wanted to use my container to play around with Jekyll on your own time, you can actually see all the information I've provided and documentation on how to use it on Docker Hub or on GitHub.